Here's where we can use quadratic equations to solve problems. Now, the first thing is that many times students will get a quadratic equation problem confused with a maximum minimum problem. And they'll start thinking about, oh, I've got to do that negative b over 2a to find the answer. Okay? If it does not say the word maximum or minimum in the problem, then it's one of these. It's only a maximum minimum problem if it says the word maximum or minimum in the problem. None of these problems will say words maximum or minimum. Okay. So we've got the height of a baseball is hit into the air. And we can write an equation that represents the height of the ball over a certain period of time. And that equation is the height at any point in time will be 30 times whatever the time is in seconds minus 5 times the time squared. Okay? And we know the shape that it takes. It takes a parabolic shape. Okay? Remember, this is just fancy notation. It just means h. H of t and h mean the same thing. Just different types of notation. I want to know when the baseball hits the ground. When the baseball hits the ground, what's the height? 0. So I want to find what's t when h is 0. So I replace h with 0, and don't I get a quadratic equation? Now it's kind of different looking than what we're used to, because we're used to seeing the squared positive, right? But this one's got a negative in front. How could we address that? What can we do? Add 5. Yeah, you gotta add the whole thing. Okay. Yes. So what we could do is we could take actually both of these over. We take minus 5t squared over to the other side by adding 5t squared. We take 30t over to the other side by subtracting 30t. So on the other side, I'm going to get positive 5t squared minus 30t. Equals 0. So all I did was I just moved everything from the right to the left, because that's the way we're used to seeing it. How do we solve these things again? Well, either taking the positive and negative square root or by factoring. This has got a t term, so I have to factor it. What kind of factoring? GCF. What can I take out? What's the greatest common factor? 5t. And when I do that, I am left with t minus 30t divide 5t, 6. So that means we set each factor equal to 0 to find our solutions. Well, what's t here? If 5t equals 0, what's t? 0. If t minus 6 is 0, what's t? What? 0. T minus 6 equals 0. Solve for t. 6. So there's two answers. But think about it for a second. Because remember, we're in the context of a problem. Does it make sense that the ball's going to hit the ground after 0 seconds? Like you hit a ball into the air and it hits the ground after 0 seconds? That doesn't make any sense. Okay? So we reject this one. It doesn't make sense in this problem. The only one that makes sense is if the ball goes in, it's a ball, right? Yeah, the baseball. The baseball's got to go into the air. So it only makes sense that it hits the ground after 6 seconds. So it hits the ground after 6 seconds. That's going to happen with a lot of these quadratic equation problems, is you're going to reject one of the answers because it doesn't make sense, which means there's only one answer. Sometimes there could be two, okay? But many times you're also going to reject one of them. So in this first problem, we were given the quadratic equation. This second problem, we've got to create it. The product of two consecutive odd numbers is 99. Sorry, odd integers. And I put integers on purpose because the numbers could be positive or negative. So how many unknowns are there here? 2. So when we create an equation, just like when we were creating functions in max-min problems, we call one of our unknowns x. In this case, we'll just call the first unknown number x. We don't know what it is. We also don't know what the second number is, but we know that it's the next consecutive odd number after x. So what would be an expression for number 2? What's the next consecutive odd number after 5? The next consecutive odd number after 5? 7. What's the next consecutive odd number after 29? 31. What are you always doing to get the next one? Adding 2. So to get the next consecutive odd number, we take the first one and add 2. Now to make the equation, it says the product, which means multiply. We have to multiply these two numbers, so x times x plus 2 is going to equal 99. There's my equation. I have to solve that. So the first thing I have to do is get rid of the parentheses by multiplying through, taking the x and multiplying it by x and by 2. And I get x squared plus 2x. We've got a quadratic equation that we got to factor. What do I have to do next before I can factor? Can I factor it like this, or do I have to, what do I have to do? I got to put the 99 over here by subtracting 99. Good. Now I'm ready to factor. Well, it's an x squared trinomial, so I know it's x and x. Two numbers that multiply to get 99. -9 and +11, you said? Yeah. -9, +11. Those multiply to get -99, and they add to get +2. So yes. So I've got two potential answers. X minus 9 equals 0. X plus 11 equals 0. Well, if x minus 9 is equal to 0, what's x? 9. If x plus 11 is equal to 0, what's x? -11. So there's two possible answers here, because remember, I said they could be positive or negative. So one possible answer is the numbers are 9 and what? 9 plus 2, which is 11. So the numbers are 9 and 11, because those are consecutive odd numbers, and they multiply to get 99. Odd numbers can be negative. If the first one's -11, what's the second one? -9. There's two possible answers. 9 and 11 work. -9 and -11 work. Okay, the last problem. We've got a field where we're told the dimensions. One of these is the length and one of these is the width. We'll put parentheses around them. And we know that the area is 36. From that, you're asked to find W. Well, how do I find the area of any rectangle? Length times width. So this times this must give me 36. 2W minus 5 times W minus 3 must equal 36. I have to solve that equation. Notice you can't jump to the 2W minus 5 equals 0 and W minus 3 equals 0, because we don't have 0 on this side. We got to multiply this through. We got to bring this over, and then we got to factor. So we got some work to do. How many multiplications here? 4. So 2W squared minus 6W minus 5W plus 15 equals 36. I can simplify the left side a little bit more by combining the minus 6W and minus 5W into negative 11W. It's still not ready to be factored yet because there's a 36 on the right. So I got to move this 36 over by subtracting 36, which means I got to subtract 36 on this side. So I get 2W squared minus 11W minus 21 equals 0. Okay, somebody tell me what to do. Okay, so what am I going to write here? Good. Nice. Yeah, now we got to figure out two numbers that multiply to get negative 21. Okay, let's try that. So I know that this works, and I know that this works, but I've got to do the rainbow to see if this works. and I get positive 6W, and I get minus 7W, that's not going to make negative 11, is it? It's going to make a completely different number. So when we see a completely different number, we want to switch the numbers. Okay, so let's try 2W minus 3 and W plus 7. Now I got to check the middle number to see if I get negative 11W. I get 14W on the outside when I multiply. I get minus 3W on the inside. That gives me positive 11W. So I just got to switch the signs. So I had to do a little bit of work on this one. A lot of times you guys will do these things in your head until you figure it out. But it's okay to write them out and make a mistake. Okay? It's okay to do that. There is no prize for getting it on the first try. Okay? There's no prize for that. Or if there is, you're going to get the same prize if you get it on the third try. So this one would actually be 2W plus 3 times W minus 7 equals 0. These ones didn't work. So we finally got them. Remember, factoring is just one step towards solving. So I've got to make 2W plus 3 equals 0 and figure out what W is. And I got to make W minus 7 equals 0 and I got to figure out what W is. So how do I solve for W in this one? What do I do first? Subtract 3, so I get 2W equals negative 3. And I get W equals negative 3 over 2. And this one, I get W equals 7. So is there two answers? Think about the problem. Can I reject one of the answers because it doesn't make sense? Well, it's okay to have two different answers. But look at the two answers I got. Can I reject one of these because it doesn't make sense? What's that? Say it again. You're thinking, okay, you keep tell me. Yeah, why can't you have a negative? Doesn't make sense. Is that what you were trying to say? Say it. We can't, yeah, we reject this one because you can't have a negative width. I just finished saying, you guys, it's okay to make mistakes sometimes. Take a chance. Okay? Okay. So that takes care of solving quadratic equations by factoring. We did a whole bunch of practice questions yesterday. We saw how we can use them in word problems today. There's one more type of method because sometimes you're going to get an equation like this that you can't factor. So what do we do when you can't factor? Well, we got a special formula you can use, and we'll talk about that on Monday. So for Monday exercise 3.3, please.